Hello students, welcome to Meetu maths classes. Today we are going to start with exercise 2.2 of class 12 NCERT chapter 2, that is inverse trigonometric functions. So let us take our first question. Prove that 3 sine inverse x is equals to sine inverse of 3x minus 4x cube. So you have to prove this identity. Now to prove this identity, where x lies between the closed interval minus half to half. So to prove this, let us start with consider our right hand side. So the right hand side of the expression is sine inverse of 3x minus 4x cube. And now you can observe that to convert sine inverse this expression into sine, we can make a substitution, and the substitution should be put x is equals to sine theta. If we substitute x is equals to sine theta, then 3 sine theta minus 4 sine cube theta can be replaced by sine 3 theta. Okay. So your expression right hand side will become sine inverse of 3 sine theta minus 4 sine cube theta, and this can be replaced by sine 3 theta. Okay. Now our right hand side will become this. Now we know that sine inverse of sine x is equals to, we know that sine inverse of sine x is equals to x for all x belongs to closed interval minus pi by 2 to pi by 2. So we are going to check that whether 3 theta lies between minus pi by 2 to pi by 2 or not. Now let us consider this limits. We know that x is lying, x belongs to minus half to half, closed interval minus half to half. That implies your x must be greater than equals to minus half and less than equals to half. Now we have substituted x as sine theta. So sine theta is lying between minus half to half, and this will implies that theta must lies, because sine theta is an inverse function. So when sine theta is increasing, your theta is also increasing. So it will lie in between sine inverse of half minus half and sine inverse of half. Sine inverse of minus half minus x is minus pi by 6, and sine inverse of half is pi by 6. If theta is lying between minus pi by 6 to pi by 6, then 3 theta, अगर आप 3 से मल्टीप्लाई करते हैं, will lie in between minus pi by 2 to pi by 2. That implies that 3 theta belongs to the closed interval minus pi by 2 to pi by 2. And we know that if sine inverse of sine x is equals to x, if x is lying between minus pi by 2 to pi by 2, since 3 theta lies between minus pi by 2 to pi by 2, so 1 implies that our right hand side is equals to 3 theta. And what is theta now? Theta can be written as sine inverse of x. So 3 times sine inverse of x, and that is your left hand side. Your second question is, prove that 3 cos inverse of x is equals to cos inverse of 4x cube minus 3x, where x lies between closed interval half to 1. Now to prove this identity, let us consider our right hand side, because the right hand side is quite complicated. So right hand side will be cos inverse of 4x cube minus 3x. Now, to convert 4x cube minus 3x, we can make a substitution that put cos x, or you can substitute x as cos theta. Okay, then we know that 4 cos cube theta minus 3 cos theta is equals to cos 3 theta. So our right hand side will become cos inverse of 4 cos cube theta minus 3 cos theta. Okay, and this can be replaced by cos 3 theta. Now we know that cos inverse of cos theta, we know that cos inverse of cos x is equals to x when x is lying between closed interval 0 to pi. Okay, so now we are going to check whether 3 theta is lying between 0 to pi or not. Now we know that our x lies between, x belongs to half to 1. That implies your x is lying between half to 1. And x, what is x? X is cos theta. So cos theta is lying between half to 1. Now, if cos theta is a decreasing function, if cos theta is lying between half to 1, then theta must lie in between cos inverse of 1 to cos inverse of half. Okay, so cos inverse of 1 is what? 0, and cos inverse of half is what? What is cos inverse of half? That is pi by 3. Now if we multiply with 3, then 3 theta must lies between 0 to pi. So we know that 3 theta belongs to closed interval 0 to pi. So using this formula, we can write our right hand side as 3 theta. Okay, and we can replace theta with cos inverse of x. So this can be written as 3 into cos inverse of x, and that is your left hand side. Hence proved. Now question number 3 is, prove that tan inverse of 2 by 11 plus tan inverse of 7 by 24 is equals to tan inverse of half. Since in this identity left hand side is complicated, so we are going to start with our left hand side. So consider left hand side, that is tan inverse of 2 by 11 plus tan inverse of 7 by 24. Now there are two tan inverse function and we have to add them, and there is a formula that tan inverse of x plus tan inverse of y is equals to tan inverse of x plus y upon 1 minus xy if xy is less than 1, and this is equals to pi plus tan inverse x plus y upon 1 minus xy if xy is greater than 1. Now we are going to check 2 by 11 multiplied by 7 by 24, and this is equals to 7 by 132, that is less than 1. So we are going to substitute this formula. So using this formula, our left hand side will become tan inverse of 2 by 11 x plus y upon 1 minus x into y. Okay, and this can be written as, अगर आप LCM ले लेते हैं, then 48 plus 77 divided by 264, and this will be 264 minus 14 upon 264. Now 264 will cancel out and you are left with tan inverse of, this will be 125 and 264 minus 14 will be 250, and this is equivalent to tan inverse of half, and this is your right hand side. So hence proof. Now your question number 4 is, prove that 2 tan inverse half plus tan inverse 1 by 7 is equals to tan inverse of 31 by 70. Now to prove this identity, let us consider left hand side, and our left hand side is equals to 2 tan inverse half plus tan inverse of 1 by 7. Okay, now there is an identity. If you have to change 2 tan inverse x, आप tan inverse x को क्या लिख सकते हैं? You can write sine inverse of 2x upon 1 plus x square. You can write cos inverse of 1 minus x square upon 1 plus x square. And you can write this 2 tan inverse x as tan inverse of 2x upon 1 minus x square. But our requirement is to change 2 tan inverse something into tan inverse of something. So we are going to use this formula, and using this formula we can write tan inverse of 2x upon 1 minus x square. Okay, and this is tan inverse of 1 by 7 only. Now this will give you 1 upon 1 minus 3, 1 by 4. And this can be written as tan inverse of 1 upon 3 by 4, that means 4 by 3, plus tan inverse of 1 by 7. Okay. Now again we can add 2 tan inverse functions using the formula that tan inverse x plus y upon 1 minus xy if xy is less than 1, and pi plus tan inverse x plus y upon 1 minus xy if xy is greater than 1. So here we are going to check 4 by 3 multiplied by 1 by 7, and that is equals to 4 by 21, that is less than 1. So we can write this as tan inverse 4 by 3 plus 1 by 7 upon 1 minus 4 by 3 into 1 by 7. Okay, and this is equals to tan inverse of 28 plus 3 upon 21 divided by 21 minus 4 upon 21, and that will give you tan inverse of 28 plus 3, 21 will cancel out, this will be 31 by 17, and that is your right hand side. So hence proof.